Okay, folks, it's 4 o'clock. Yep. And today I'm going to be doing 3 problems for you. Just a few comments about what is left to do. Well, first of all, you're going to have material that you're responsible for till the last day of the course, okay? And this Friday, after I do this session for you, you have seen all the joints that are needed to do anything in the course. And on Friday and maybe on Monday, I will show you some programming to do in these mechanisms. Notice, for example, the problems that we have done when it came to applying physics. We said, oh, the velocity is this, or the acceleration is that number. Now, there may be a situation where the velocity during a certain time, for example, is constant, and then the velocity in it, then it becomes 0, then it changes to a different constant, etc. So you really have to have some ability to do if statement type things, programming type things in your code, in your CATIA. And we will do that. We will do that on Friday, okay? And as I said, if there is a need, we'll continue a little bit more on Monday, and then we put this stuff aside. The remaining 4 or 5 lectures is going to be using the design table that you're going to see, not to worry. Okay, in the problems that I'm going to do, the reason I do 3 of them is that I'm not going to worry about dimensions. I'm not going to put any physics into it. Those are things that you have already done and you know how it's to be done. Okay, so for this session today, we're going to see some joints that we have never experienced before. Well, first of all, before I start this problem, are there any questions? Okay, no questions. So here's the problem that I'm going to do, and it's called the telescopic mechanism. First of all, let me show you what I have in mind right there. This is what I'm going to do for you. Let me cancel that. Bring it up to 0 position. It is at 0 position. Okay, now simulation. Okay. Not this. We already had one, but I'll make another one for you. Insert, rewind, and play continuously. So I'm going to create this mechanism for you. Basically, there are 2 tubes, one inside the other one, and this tube can be going slide up and down the outer one, okay? Like an antenna, like one of these old car antennas and things like that. And one end of the tube is, there's a spherical ball there, or it's a ball socket joint, and then on the top, this top point traverses a path. Okay, so this is the problem that I want to do for you. Okay, kill this. So this is made of basically 3 parts. There is the ground. Think about it as the ground dummy, whatever. And this is where the spherical ball is going to be. And I do need a point. You'll see why later on. But this point does not have to be the center of this, or does not have to be anywhere special. And I have a comment on what to do so that you don't get into trouble to create that joint, that point later on. And of course, there is going to be an outer casing, an inner casing, and that top point at the inner casing is going to go on the curve, and the bottom point on the outer casing is going to go to that ball socket joint. Okay, ball socket mechanism. All right, let's start. Let's go here. Let's start with a product file. Remove these things out of the way here. Okay. So product. immediately save it. File, save management, save as, desktop, new folder. I'll call July 2021. Okay, I put it there. July, and I'm going to put a 1 so that I don't have to look for this all the time. Rename a 1 there. Okay, we're going to insert our first part, which is the ground or the dummy or the base, whatever you want to call it. So where are we here? Yeah, assembly design. Insert a new part in there. Yeah, let me call it dummy, whatever. No, actually, I'll call it ground. I don't like dummies. Ground. And ground. Where is that guy? Ground. Okay. All right. So let's make it. Well, first of all it is, there's 1 point down here at 0, 0, 0. That's where the ball socket joint is going to be. And then I want to draw a path somewhere up here. So let me make a plane here, a plane offset from that plane, and I'm going to go further up. So I'm going to draw that path or circle on top on this plane. Where did that go? Did I cancel it? Yeah, I think I canceled it. Okay, offset from this, up, 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 up. Okay, good. Now on that, I will sketch a path. You know, maybe a circle, ellipse, whatever you want. It really doesn't matter. Let me draw an ellipse. Okay, exit. Okay, now later on, I want to put that inner tube on this path. So let me create a point on that path, on a curve. Doesn't matter where, because eventually I want to bring that inner tube and make it coincident with this location. And notice that in this drawing, I have another point, but I'm not going to do that point right now. Okay, I'm not going to do that point right now. The one that I made is not the one I'm referring to. Okay, that's it. Save everything. Then I'm going to insert the outer tube. So insert new part, outer, outer, outer. Okay, let's make it. So on a convenient plane, on that horizontal plane, I will sketch, 2 circles, because I want to make a tube out of it. Dimensions not important in this problem. In real world, it is a problem, not in our course. And there we are, you can see that. And then we pad it. Up, 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 up. Yeah, that's good. Okay, good. And I want to point at the bottom of this, because that eventually is going to be placed on top of this point, and it's going to become a spherical joint. So while we're in this part, I'm going to create a point at the center of that circle, right there. We say, okay, that takes care of our second part. So save everything. And then I'm going to insert the inner tube. I'll call it inner rod. How about that? Insert. Okay, where is this? New part. I'll call it inner. Okay. Right click, properties, inner, and inner. Let's make it. Okay. So I'm going to draw on that face a circle that size, which means I can easily project that. Okay. Exit. Palette. So this inner one is going to get inserted into that. And hopefully these are long enough so that they can reach the curve. It really doesn't matter because you can still do the problem. It's just that this may depart from that casing, but yeah, that's okay. So actually, let me make this thing a little bit longer, perhaps. Okay, and make this thing also a little bit longer. I don't think I need it, but anyway. Okay, very good. Good. And I need a point at the top of this part. This part, we're in the inner rod or inner tube, and circle. No, circle. No. What did I do? Okay, I think I closed it, which is good. I want the center of a circle. That circle. Center of a circle. Where is that? That, right there. Okay. And then we're going to save everything. This is all done. We're going to go all the way to the top and save everything. Okay. Now, let's start putting assembly constraints here. So let's anchor the ground. Very good. I'm going to put this point coincident with that point. That point at the bottom of that outer tube coincident with this. And you know what's going to happen. When you make 2 points coincident, that's going to become a spherical joint, ball socket joint. And in fact, that's exactly what I want here. Okay? So update. There we are. Okay. Now I'm going to insert this guy in that guy. And I'll let it go up and down, but I don't want it to spin. Because if it spins, you have an extra degree of freedom that you cannot control. I mean, if you just put axis to axis, it becomes a cylindrical joint. It has 1 degree of freedom for axial motion and one for rotational motion. Now, I don't want that. I want this thing to be prismatic with that so that it doesn't spin. So we do axis to axis and then plane to plane. Okay? So coincident between this axis and that axis, and coincident between a vertical plane of the inner one and a vertical plane of the outer one and inner one. Or I can do angle constraint. I want to turn it into prismatic. So let's see now, a vertical plane of the inner, for example, let's say XZ, and vertical plane of the outer, XZ. You say okay, update. There we are. This can only go up and down, cannot spin, because it's a prismatic joint. It will be a prismatic joint. And I want to put this point, I want to do later on a point curve joint. A point curve joint, the point must be on the curve before you can make it. So let's put it there. So coincidence between that point and this point, which was created on the curve, and it's going to go like that. Okay, let's look at it. Yeah, I think these are long enough that they can easily spin. Even if this was short, still the motion, you see the motion, it's just that the gap will develop between the inner and outer part, which doesn't look very pleasing. Okay, so let's go and save everything. Save everything. Okay. Now, let us go to the digital mockup, DMU kinematics, get the magic wand out. Okay, new mechanism, auto create, say okay. And can you tell me, let me see if somebody can help me with this. Can you tell me what kind of joints I'm going to get there? If I open this up, can you guess what kind of a joint you're going to see? All you have to do is to say a couple of words. Is that too hard? I'm not going to say anything because then I have to edit it on for posting on YouTube. All right, no problem. We have a prismatic joint right there. This point is going, because I did point to point, it's going to be spherical joint. And this point, because I did point to point, it's going to be spherical joint. I don't want this to be a spherical joint. I want this guy to go around. So basically, I have to delete that guy. Between the inner, I have to delete this joint because otherwise can't move. Okay. Now, the point curve joint, you have no choice but to do it yourself. Point curve joint. There is a curve, and there is the point. Notice that it won't let you take it because there's 2 points sitting on top of each other. One of them is on the curve. The other one is at the end of the inner rod. You cannot take the one that is probably on the top is the one for the inner, for the curve. That's why you cannot choose the curve from the same part that the point is. So the easiest way, either you hide these and get to the bottom of the thing, or you go to the inner one. This is from the inner point. Notice it took it. Now the degree of freedom is 2. Well, first of all, we can make that spherical joint does not have a command. Prismatic one does, but the better way is doing the point curve joint, make it length driven. And of course, this means that the length of that curve is 34 inches, which is fine. Now, this is 1. And you can spend a lot of time trying to fix it. You have a problem. You might say, well, wait a minute. What if I make this thing 1? Yeah, well, this is not going to work. Okay, so let me go back. So here's what I'm going to do. This, right now, both of these, the inner and the outer tubes, have the ability to rotate about the axis of the outer tube. You see that? Now this guy can only go up and down the tube without rotating, but the outer one can. The outer one can spin because this was a ball socket joint. It can spin. So what I'm going to do, I'm going to make sure that a plane, a vertical plane of this outer one, always goes through a point fixed in space, which takes away that rotational motion. And that point, I'm going to put it on the ground. So here's the easiest way of doing this. And notice that you read this, and it basically says what I just said. Right before creating a point surface joint, go to the ground part and create a point shown on the top left corner, this one, in the YZ plane of the outer part. So here's what it's saying. Go to the outer part. Go to the outer part. Go to the ground. Go to the ground. There. Go to the ground. Okay. Create a point, but make sure that point is on the YZ plane of the outer part. So outer part is here. I'll keep it here. Ground, outer part is here. I'll keep it handy. So create a point. Right now, I'm in the ground. I am in the ground. Create a point on a plane. And that plane, I'm going to take it from the YZ plane, for example, YZ plane or XZ plane of the outer part. And it really doesn't matter where. I don't care. Okay, it doesn't matter. Okay. Now I'm going to go back to the digital mockup and create a point surface joint. You have never seen this. Point surface joint. Point surface. For the surface, you use that YZ plane of the outer part. And for the point, you select this point that you just created. Now, the reason I went and created a point in the YZ plane, because to make a point surface joint, the point must be on that surface. The surface here is that plane, basically. That's what it is. Mechanism can be simulated. So you go, I don't know, you try this. Okay, create your mechanism. Okay, move, insert, rewind, change anything but one, and play it continuously. The only tricky thing in this problem was that you wanted to make sure that this outer casing was not spinning, because the bottom here, that bottom here is a spherical joint. This can spin, okay? Now, I wanted to take away that motion, spinning motion, and the trick was to use a point curve joint. The point out there, the surface, the surface is the YZ plane of this outer casing, and the trick was that I created that point to be on that YZ plane so that point surface joint can in fact be created. Now, there are other ways of doing it. Are there any questions? Are you responsible for these kind of things? Yes, you are. You're working on these, right? Okay. Now, let's go to the second problem. There we are. So we have a cam. There's a cam, which is stuck into that wall with a shaft, and it is rotating at a constant speed. And there's a pin here that goes up and down. You know, this is very good. This is very common in internal combustion engine. So what I'm going to do is I'll make this thing for you. The physics of it is, of course, giving the RPM of the cam. Then you have to find out what is the acceleration of this pin going up and down, what is the velocity of it, and things like that. And I'm not going to put the physics into it, okay? Now here, again, I'm going to be using a point surface joint. So you, in the book, if you're following the book, if you have a copy of the book, whatever, I've extracted the surface of that cam. That is not necessary, okay? That's what this is saying. Read it yourself carefully, and you'll find out. So let me kill this. So file, new product, save it immediately, file, save management, save as, up, there we are. Okay, I'm going to make this thing a new folder, cam problem. There we go. Rename cam. Okay, let's put it in there. I don't have to worry about this product one overriding the other product. I'm going to have three parts: the wall, the cam, and the pin. So insert new part in there. I'm going to call this thing the wall. Right click properties, wall. Wall. On that vertical plane, actually on this one, I'm going to sketch something that looks like an inverted L. That's going to be my wall. No dimensions here, okay. Dimensions are just slowing us down. Okay. exit, pat it. Okay. So I need a hole up there. The pin is going to go in it. So on that face, I will sketch. I'll draw a circle here. That's where the pin is going to go. My pin is going to be not as elaborate as this guy. I just draw a cylinder. Make a pocket. Okay, that's the hole for the pin. And then I'm going to make a hole for the shaft here on that face. I will sketch. Yeah, something like this. That's for the shaft of the cam. Pocket. Good. Save everything. Okay, insert the next part. Insert new part. How about the pin? In there. Pin. Pin. Make it. Okay, so I want a pin with that cross section. So on that face, I will sketch. Fit it. Project that circle. Exit. And pocket. Not pocket, path, sorry. Mirror extent. Let's make it more. Yeah, that's good. Now, I urge you to do this problem with a pointy tip like that. Let's see if we can do it. Okay. Now, first of all, I need a point here. So a point, center of a circle. There. Good. This is all done. Save it. Then we're going to insert the cam. Insert, new part. Right-click, properties. This is going to be cam. Cam. Double click on it and make it. So on this face, I will sketch. Well, a circle that size. That means project that. By the way, why we'll add it, if you want to, if you want to change the radius of that, make it smaller, for example, you won't be able to do that because you have done a projection. Let's see if we can dimension it. We can dimension it, of course, and it's going to tell you what it is. But notice that it's put in parentheses. That means this depends on something else, and you cannot change it. Even if I try to make this thing, I don't know, 0.02, 0.03, well, it won't do it. Now, if you want to do that, I don't want to, but if you want to do that, you put the cursor on this yellow thingy, the one that you drew right there. Let me sketch. Let me hide this. Okay. Put the cursor there, right click, and you say isolate. When you isolate it, that is no longer yellow. It becomes white. And now you can dimension. I don't want to do that, but all I'm saying is that sometimes you may want to project for convenience and you want to be able to change it. If it's a direct projection that is that yellow color, it won't let you do that. But if you isolate it, and then you can move it around, you can do all kinds of things with it. I don't want to do that, but anyway, exit. Where's my wall? There's the wall. Okay, and then, oh yeah, and then pad it. Pad this. This is going to be the shaft of that cam. Let me make it. Yeah, that's good. And then on this face, I will sketch something that resembles a cam. Cam design is not an easy thing. You have to have, I don't think you're doing it in your machine design class, but this is the kind of thing that is done in a machine design course. Not the first one probably, but it's very important. These profiles are not arbitrary. You know that, okay? Because these profiles will give you information on the acceleration and the velocity of these things. Okay, let me actually make this thing a little bit bigger. No. Terrible. Okay, so let me make these things look nicer. So this curve control that curve. Obviously, you cannot have a sharp corner like that in a cam. It goes nuts. Tangent. And this control that tangent. Notice that I did not make this concentric to that because I don't know, it depends on your cam requirements. So exit and then pad it. Okay, very good. Let me make this thing a little bit bigger, maybe 1.5. Now, first of all, let me save this. If you're doing it by extracting a surface as is done in the book, if you want to create the surface of this, it's not the surface, but if you want to create the surface of it, you're going to have to go to this part, which is cam. Go there. And then you have to switch to generative shape design, because as soon as you say surface, you need to go to generative shape design. Surface, you cannot do it in part design. And then there is extract somewhere. Find it. We have done this thing in finite elements right there. You see this? Right there. If you pre-select all of them, control, 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 and control, and extract, it's going to do all surfaces associated with that thing. And in fact, you can hide that. If you want, you can hide it. And it's going to be there. Now, you can do this thing. In the book, I'm using this to create my point surface joint, but I told you that it is not necessary. So I'm just going to just leave it alone. I'm going to delete these. I don't need it. That's all. Not in this problem, at least. Okay. My cam is still here, is in hiding. Okay, good, good. Let's assemble. Go to the assembly design. Okay, first thing we're going to do is to anchor this wall. See that? Because yes, because here I'm stuck in the part right there. You have to double click on that to get into these things. Anchor the wall. Make a revolute joint between these. Coincidence between this face and that face. Update. Okay. Coincidence between this axis and hide it, that axis. And again, we don't want this thing to spin. So you make a coincidence between vertical plane of that pin and vertical plane of, for example, the wall, so that it takes away that rotational motion. Basically, this becomes prismatic anymore. So vertical plane of the wall, for example, YZ, and vertical plane of the pin. That makes this thing prismatic. And the reason that you don't see any update here, because the way I constructed it, it's already in that configuration. Now, that's pretty much it. So let me get the pin here. Okay. There's something that I have to do that I'm not going to do it right now. Okay, and you see that that's going to cause a problem. So first of all, we're going to save everything. DMU kinematic. Get the magic wand out. Auto create. This is going to be a prismatic joint. This is going to be a revolute joint. And it's not surprising degree of freedom is 2, because you have a revolute, degree of freedom 1, prismatic, degree of freedom 1, and this is going to be total degree of freedom. Now, I want this point to be on that surface. If I actually literally created the surface, I would say point on that surface. But here, I can select this thing. Okay, so let's see. Point surface right here. We just used it in the first problem. Between that surface and this point. And it says you can't do that because there is 31 millimeter gap between them. You can't create a point surface joint. Same way that you cannot create a point curve joint. Cancel, cancel. So we're going to go back to assembly. Bring that thing down and put it here. This is why in the first problem, I created that extra point on the YZ plane of the outer casing to make sure it's on it and I can create it. So first of all, we're going to say coincidence between this point and that and update. And now I'm going to go to the DMU kinematic and create my point surface joint. So the surface is here. The point is there. It's not complaining anymore. Degree of freedom is 1, and we can make that angle, that revolute joint angle driven, because after all, you know the RPM of the shaft, or the cam mechanism can be simulated, and we are not doing any physics. You will get physics things on the test, so make sure you're prepared for it. You will be asked to generate stuff, generate curves and things like that. There we are. Okay. Any questions? Okay. Third problem. A C-clamp mechanism. This is the kind of thing that you use when you do woodworking and stuff like that. Put two pieces of wood together, put glue in between it, stuff like that. Okay, so that's what we're going to do. So I'm going to do this problem without any dimensions. And okay, let's go ahead. Kill this. A new one. Immediately save it. Desktop. In that folder, a new one, C-clamp. Remember that C-clamp, we have done it in finite elements. We want to know what the stresses are in that clamp, because if they're too big, that clamp is going to break in the places that you know. We know where is the most critical place. There. Remember the C? Right there. Okay. All right, so I'm going to insert my first part, which is just the C, and the second part, which is just the handle. Okay, so yeah. What are we doing here? Not there. Assembly design. So insert, new part, in there. This first one, I'm going to call it the C, properties. That's the clamp itself. C, make it. Part design, right? Okay, on that plane, I will sketch something that looks like the C without all the fancy fillets and things like this. Exit. Exit. Pad it. Make it 2. So it looks like. Okay, that's good. I like it. So on that face, I will sketch. Okay. Circle like this. Exit. Do that. Do it on the wrong place. I want this thing to be. Come on. Yeah, okay. So it's too big. That's fine. Okay. Exit. It's not centered, but that's okay. All right, so pad it. Too much. Point, I don't know, 5. Good. On that face, sketch. Okay. Let me put it in the normal mode. In fact, I'm going to change the rendering here so that I can see what I'm doing. Okay, so a circle like that. We're gonna make him concentric. That control this. Cancel. Let's try again. This control that concentric. There. Exit. Pat it a little bit. Yeah, okay. So let's see what I've done. There. Maybe I'll make this thing longer. How about 2? Good. Terrible. Okay, so now I'm going to do the handle. Oh, I need a hole here. I need a hole because the handle is going to go through this hole. So on that face, I will sketch, project that circle. Exit, pocket it, flip. No, not pad, cancel, pocket. Good. Okay, let's go and insert the handle. So insert, have to go to the product right there. Insert, new part. No. Right click. Properties. Handle. Handle. Ooh, too many things here. Handle. Handle. Let's make it. Double click on it. All right, so why don't we do this? On that face, we will sketch. Okay, let me project this, project this little one. Good. Exit. I'm doing this in the long way. You know, there are shortcut ways of doing stuff like this, multi-pad and things like that. You don't have to draw as many things. On that face, I will sketch. Project that guy. Exit. See, this was a lot of extra steps that you really didn't have to do. 0.5. Ooh. All right, no problem. Let's make this thing longer. Actually, I want this thing even longer. How about making 4? Okay, no problem. Let's go back there. Let's go back there, move it down a little bit so that we can see what's going on. Move this thing down. Here, that's what I did. Okay, and we're not done with this handle, so we go back to the handle. Okay, on that vertical plane, I will sketch, because I want to draw the handle. This is not the handle, actually. The handle is right here. So let's go ahead. Something like that. Exit. Add it. That's what the handle is. And on this side, I want to go all the way to that surface, okay? So more, go to that surface, to this surface. And maybe even, I can even go further. Actually, you know what? Let's not go to the surface. Let's get a dimension. Stick it out on the other side. Okay, good, good. So the threaded part of this handle is actually down here. So this is it. Save everything. All right, let's go ahead and do the assembly. So anchor the C. Okay, good, good. You know that this guy is actually a cylindrical joint, right? Because it not only turns, you turn the handle, this goes up, right? So coincidence between this axis and that hole. And let's bring it up. So this is it. Let's go ahead here, save everything. Go to the digital mockup, DMU kinematics, get the magic wand out, new mechanism, auto create, and okay. Okay, so if you look, there's going to be a single cylindrical joint here. And notice that the degree of freedom is 2 because a cylindrical joint has 2 degrees of freedom, one for turning, one for advancing. Okay, but here there is something called a hang in there. Let's say universal joint. I don't want it. I don't want it. Oh, screw joint. Screw joint. Screw joint. Screw joint. A screw joint is like, if you know the handle, you have two things in it. One is, well, actually, this is what I wanted to do, okay? So let me go ahead and delete this damn thing. This is going to be fine. There's nothing wrong with it. It's just that the C-clamp problem, we're going to do it with screw joint. Screw joint, what it's asking is two lines. This line and hide that. Undo, undo, undo. The axis of that guy and the here and this. That's all you want. And it says, what is the pitch? In other words, for every turn of a handle, how much does this advance? So this, I don't know what the unit of this thing is. Let's put down 10. And this can be angle driven or length driven. So for example, how many turns you make angle driven? Mechanism can be simulated. Oh, come on, go back. Okay. So mechanism can be simulated, and if you look at the simulation, when you turn this thing by 360 degrees, it advances by 10, whatever I put down there. I think it was 10. That must have been 10 inches. I'm not sure, 10 millimeter or 10 inches, because I don't have an idea how big these things are. So anyway, we could have done that problem with a cylindrical joint, but I wanted to show you how to use a screw joint, okay? And a screw joint, all you do is basically a cylindrical joint, but you specify the pitch, okay? In other words, every 360 degrees, how much it advances. In a cylindrical joint, these are not related to each other, okay? You can make it related to each other, but a screw joint, it says every turn that you make, how much does this thing go up and down, okay? So there we are. Save. So let's see what is it that we have not used here. We have done revolute, prismatic, cylindrical, screw, spherical, planar, rigid, point curve, slide curve, roll curve, what is that? Point surface, CV joint, that's the one that you use for, well, actually, this is the CV, what is that? CV joint. Yeah, this one is the universal joint, okay? Gear joint, rack joint, cable joint I haven't used. It's a very simple problem. So we have used, except for this cable, that if you are interested, you can figure it out yourself. And this CV joint, we have done a universal one. Oh, this is the universal one. We have not used a CV one. Every joint we have created. So as far as this portion of the course is concerned, you have seen everything that needs to be seen. And the only thing that needs to be done is a few more programming hints on how to specify formulas and things like that, where things are not as simple as just writing one line. So far, you have done only formulas. And folks, this is it. See you later.